morning, grade 8s, and welcome to another video where I am going to be discussing paper 2 topics for grade 8 paper 2. So please, if you are still going to write paper 2 and you want to revise through the work, I've got 3 videos that I'm making on all the major topics of a paper 2 mathematics paper exam. Okay, so I've done the first topic, which was geometry. So if you haven't seen that one, you can go look. I think I've loaded it up yesterday. And then today I'm going to do 2 videos for you. The one is on measurement. So that is volume, area, perimeter, surface area, etc. All those lovely topics that you love doing. And then I'm going to do one more video on data handling. So those are your 3 main topics for paper 2, although you must just double check with your teacher what her scope was for the exam so that you make sure that you cover all the topics. But in our school, paper 2, normally up to matric, we have those 3 topics evident in a paper 2. Okay, so what I've done is I've taken all my exams from the past year and I've worked through all the grade 8 ones, and then I copied and pasted all the different sections into each section where it belongs to. So these are questions from all my past exams over the past roughly 16 years of me teaching maths, which I've just taken a few that I think is could help you, that you can go through and that you can learn from. All right, so it's just a few, it's not all of them. And what else did I want to say? Yeah, just bear with me, work through with me. Maybe you can pause the video, look at the question, see whether you can do it, and then unpause and then or resume the video, and then you can just double check whether you got it right, and you can skip through and do the question, check that your memo is right, and move on. All right, so because we want you to do well, but most importantly, we want you to understand the mathematics, all right? Not just learn it to do it. All right, let's quickly start. So first one, this was a section A question. It was very easy. We just wanted to see whether you understand these formulas. And these formulas aren't ever given to you in a paper. So even in matric, when you are given a formula paper, you must know these formulas still. They won't appear there. Okay, so the area of a square is side times side. So A is 4. The circumference of a circle is 2 pi r, which is number 1. The area of a triangle is half base times height, or base times height divided by 2. So that one belongs to number 5. The area of a rectangle. So the area of a rectangle is length times breadth, which is number 2. The volume of a rectangular prism. So a rectangular prism looks like that, like a box. And that would be length times breadth times height, which is number 3. And hopefully the last one matches with the one that we haven't used, which is this number 2 over here. Have we used 6? Let me just quickly number 2 we've used, which is number 6 over here. The area of a circle, yes, that is pi r squared. Okay, so just make sure before you go into the exam that you know these formula and that you can apply them, because if you don't know them, you won't be able to do the sum, which hence is giving you won't result in any marks. Okay, question 2. ABCD is a square with an area of 49 centimeters squared. So we know that if you've got the sides, if I don't know the sides, they will all be x. And then they say to you, determine the length of one of the sides of the square. So x, we know the formula for a square is length times length, which is x times x, which gives you x squared. And they're telling me that the square is 49 centimeters. So x squared is equal to 49 centimeters. So then I'm going to square root. So x will either be plus minus, but because it's a distance, it's always a positive. Perhaps your teachers haven't started drilling that into you yet. But when you square root a number, your answer will always result in a positive and a negative answer. Okay, but in this case, we're just going to focus, and don't stress so much about it in grade 8. We're just going to focus on the positive numbers. So 7. 7 times 7 will give you 49. You could have done it by trial and error and just say what times what gives you 49. And hopefully you knew that was 7. And so the length of a side is 7 centimeters. Okay, list 2 properties of a square. How easy is that? You can say all sides equal. You could have said opposite sides are parallel. You could have said that all angles inside equal to 90 or is 90 degrees. Yeah, any two properties over there. All right, and here they say to complete the sentences. So this is also still a level like a section A type question, very easy, straightforward. Complete the following sentences. So a bit of geometry in here as well. Alternate angles are if two lines are parallel. So alternate angles, remember your alternating angles. So over there, they are equal to each other. I just wanted to get another color. Two parallel lines from co-interior angles which make two angles equal to. So two parallel lines form co-interior angles. So if you've got two angles, remember together they will give you 180. Something opposite angles are equal to each other. Something opposite angles are equal vertically opposite angles. Sorry, I also had to think there now. Okay, vertically opposite angles are equal to each other. The opposite sides of a palm are either parallel or equal. The diagonals of a kite are what to each other? So the diagonals of a kite are perpendicular to each other. So I don't know if you remember that. Perpendicular. Could have also shown that, because if you've got a kite, the diagonals will meet at 90 degrees. This shape only has one pair of opposite sides parallel. Give the name of this shape, and that is our lovely little trapezium. All right, so maybe look there, see whether you would have been able to answer all those questions. Okay, question 3. Complete the following table. So here they ask you what is the perimeter and what is the area? Or if it's a circle, what is the circumference and then the area? So with this one, it's got a measurement of 5 centimeters each. So what would be the perimeter? Okay, so it will be 5 plus 5 plus 5 plus 5, which gives you 5 times 4, or you could have said 5 plus 5 plus 5 plus 5 gives you 20 centimeters. What would be the area? The area would be 5 times 5, which gives you 25 centimeters squared. Okay, just be careful for your units. Make sure that you use it correctly. The perimeter is just a length, so you're not going to have any square or cube, and the area is always going to have a 2 because you're working with two-dimensional shapes. And what would be the area of that? Okay. The diameter over here, okay, so they give you the diameter is 5, but most of unless you use another formula, you could also use another formula, we use the radius, which gives you 2.5. Okay, so the circumference of a circle is 2 times pi times radius, which gives you 2 times pi times 2.5, which gives you 15,7. And if they don't say anything about rounding off, we always round off to the nearest 1 decimal place. That's with the IB. It could be different with the GDE, I can't remember now. And then the area is pi radius squared. So pi times the radius times, pi times the radius squared, which gives you 19,6 centimeters squared. Right, with the triangle, the height given me here is 3, the sides are 5, and the base is 8. All right, okay, so the perimeter is just 5 plus 5 plus 8, nothing to do with the inside there. The perimeter is the outer lengths of a shape, which gives you 18 centimeters, and then the area is base times the height divided by 2. So 8 times 3 divided by 2 gives you 12 centimeters squared. Okay, not so hard. Hopefully. Okay, question 4. Let's have a look. Determine the length of the unknown sides specified in each question. Show all your calculations. Okay, so they tell me that the area is 81. So again, if you square root 81, you'll get that each side is going to be plus minus 9 centimeters. So it's going to be a positive 9 because we're working with distance. So what would PQ be? It would be 9 centimeters. Okay, you could have shown your working out. I'm sure if you just said 9 centimeters, you would have gotten your 2 marks over there as well. Okay, now very, very important. That was all centimeters. Now, yeah, they try to fool us by giving us millimeters and centimeters. So they didn't specify, so you could have gone either way. But if you look here, I can see that that is in millimeters. So they're looking for KL. So I'm going to stick to millimeters and I'm going to change the perimeter to 2,1 centimeters. How many centimeters in a millimeter? How many millimeters in a centimeter? There's 10. So I'm going to times by 10. So there's 21 millimeters. Okay, so if this side is 5 over here, then this side would also be 5. So if you take that total perimeter of 21 millimeters and you minus the 2 sides, you get 11 millimeters left. 21 minus 10 gives you 11. And now what is left, we need to divide up into 2 because there's 2 sides that are equal length. So when I divide it by 2, I get that it is 5.5 millimeters long. All right. And it might not look like that because this is 5. How can that be 5.5? But then I always say, remember, we cover ourselves by saying in the beginning that all the pictures aren't necessarily drawn to scale. Okay. Then over here, let's quickly have a look. They tell me that the perimeter is 30 meters. So let's just double check everything that has been given is in meters. So we don't have to stress about that. They're telling me that the 2 meters over here is that side, and that side. How did I know that? Because they're all indicated with a little stripey, which means that they are all the same length. Okay, so I'm going to make a dot, and this is where I'm going to start with my adding up of the perimeter. So if you can follow me, it's 2 meters plus 1.2 plus another 2 plus 1.2 plus 2 plus x, and that side is also x. So what is this? It's an isosceles triangle. So plus 2x gives you 30 meters. Okay, now we're going to add up all our parts that we can. 2 plus 1.2 plus 2 plus 1.2 plus 2 gives you 8.4, which is equal to 30. And then 30 minus 8.4 on both sides gives you 21.6. And then if you divide by 2 on both sides, you'll get that x, like they've asked, is 10.8 meters. Okay, always double check your units. Was it a length, that they were asking me to work out? Yes, I did divide by 2 because there were 2 x's. They just asked me to calculate x, so it's just 1x. All right, so I hope it makes sense. Let me just get the picture in full there. If you want to have one last look. All right, let's move on to question B. Calculate the area of the shaded section. O is the center of the semicircle. So there is the center of the semicircle. And then they say to you, ABCD is a rectangle and OE is 7 centimeters. Okay, so now if this is a rectangle, that's all they've given me. Okay, but can you see that if OE is going to be 7, then that means that OC will also be 7 centimeters. Why is that? Because that is a radius of a circle. So if as long as it's from the center point anywhere out to the edge of the circumference, even if it's just half a circle, if that is 7, that will be 7, that will be 7. Okay, so we've got that. And what else did they want to know? Okay, so calculate the area of the shaded section. So we need to work out the area of the rectangle. And then we're going to minus, I wanted to write it again, the area of the semicircle. Okay, but please remember it's a semicircle. So what do we need to do? Immediately make a note for yourself. We need to divide the area of that circle with 2. Okay, oh, sorry, that's my dog shaking himself. Okay, so if that's 7, then this is also 7. So the length of the rectangle is 7, and the breadth of the rectangle is also, it's not 7. The length of the rectangle is 14, and the breadth of the rectangle is 7. So it's 14 times 7 that we want to get the answer of. And then we want to minus, also subtract the area of the semicircle. So the area of a circle is pi times the radius, which is 7 squared. And then we have to divide it by 2. Okay, so I hope that makes sense. So first the area of the rectangle, which is 98 centimeters squared, minus the area of the semicircle, pi times 7 squared equals divided by 2, which gives you 76,969. I'm just going to write a few there. So the total area of that shaded area will be 21,03. They didn't say round off to the nearest 2 decimals, so I'm just going to keep it as 21 because it's 21,03, and then round it off to the nearest 1 decimal, just be 21 actually. 21 centimeters squared. Okay, so I hope that makes sense, that we were able to identify that the radius is given as OC with a circle, then everywhere from the center to the edge of the circumference of the circle or to the edge of the circle will give you the same 7 centimeters. So that was very important to realize that. Then you could figure out that it's a rectangle. Because it's a rectangle, you can double it and use those measurements to calculate the area of the rectangle. Okay, so I hope that makes sense. Let's move on to the next question. Study the image of the 3D object. And the first question is, name the 3D object. And hopefully you could see that it is a right triangular prism. Okay, I can't remember now if you told me it's a triangular prism. I think I also just gave you the answer or the mark, sorry. But very important, this one is a right triangular prism. Now they say to calculate the length of AC. Now AC, can you see, if we just look closely and we redraw it, it is Mr. Old Pythagoras. And AC over here is the hypotenuse side. So the formula is going to be 7 squared plus 24 squared will give you AC squared. Okay, very important. We have to always, when we use Pythagoras, say there, thank you, Mr. Pythagoras, and name him. All right, so we get 527 is equal to AC squared. And if you square root that, 527 is going to give you a positive and a negative. Oof, is it an ugly answer? Let me just quickly make sure. Oh, sorry. It's not an ugly answer. Is 625. Okay, in grade 8, most likely you get a Pythagorean triplet, which actually just means if you're going to get the answer, it's going to give you a beautiful whole answer. Okay, it's not going to give you decimals. And the square root of 625 is 25 plus minus 25 meters, but because it's a distance, it's always positive. Okay, now they say to you, calculate the surface area of the 3D object. Now, people, the surface area is the longer one. Okay, so the volume is always quite easy and quite straightforward, but the surface area is where we have to go and break this triangular prism apart and then add all the areas together. So let's start with the triangle. And we know that the triangle is the front, and there's the triangle at the back, which is visible over here. Okay, so for the triangle, we know the area is base times height divided by 2, and luckily we've got the base, we've got the height, so it's 24 times 7 divided by 2. I'm going to do it a long way. Maybe you could have said, oh, but ma'am, couldn't you have left the divide by 2 and the times by 2 out? You could have, but I'm just going to show it so that I show all the steps. Okay, so 24 times 7. Remember, your base and your height is always linked or attached to this 90 degrees. So that is your base and that is your height. Okay, and that gives you 24 times 7 and divided by 2 gives you 84. But because there's 2 of them, I'm going to times it by 2. Which gives you again 168 meters squared. So you could have this divide by 2 times by 2. You could have just not done that and just get 168. Okay. Now, I always say with the triangular prism, there's 3 rectangles. There's this front one, there's the back one, and there's the bottom one. But this measurement that it pops out with, this 22 meters, is what is going to times with each length of the triangle's sides. Okay, so for the rectangles, there's 3 of them. And that 22, I always say he's marrying all 3 of the sides of the triangle. So if it's hard for you to see that it's 22 times that, the back is going to be 22 times that, bottom 22 times that, just remember it's this Okie. He is marrying 3 different wives. He's marrying the 7, the 24, and the 25 that we've worked out here. So if I had to write there, remember this distance over here was 25. So the Okie, this one, that it pops out with, the 22, he marries this one, and that one. So 7, 24, and 25. 7, 24, and 25. And that is your length and breadth of each rectangle over there. So 154. 528 and 550. And now we need to go and add all our totals together. So the triangles, the 2 triangles, and the 3 rectangles. So the total surface area is going to be 168 plus 154, 168 plus 154 plus 528 plus 550, which gives you 1,400. And because it was meters, am I right? Yes, it has to be meters. And because it's surface area, we're going to put a square. All right, off to our next question. A swimming pool has a rectangular shape. The length, the width, the depth. Determine the volume of water needed in liters to fill up the swimming pool if 1 meter cubed is 1,000 liters. Okay, so very important. We want to work out the volume of the swimming pool. And the volume, you don't get a mark for writing the formula. Length times breadth times height. What you get is by calculate or inserting the values correctly. Okay, so length times breadth times height, very easy. 25 times 5 times 2 times 5 times 2, and that gives you 250 meters cubed. And then I've got a video where I show you my pirate method, but how it works is you write down what you have and you write down what you want underneath the correct unit and you divide up times down. Maybe this was easy to see that you just take 250 and you times it with 1,000, then that's 100%. But that would give you 250,000. Sometimes it works nicely with units that are not so clear to see. 250,000 liters. Okay, perfect. Okay, moving on to the next question. Question 5. A little bit of a harder type question. Not so easy. There's no pictures given. There's just the wording. Let's have a look. The circumference of a circle is 64 centimeters. So now let's quickly think. What is the circumference of a circle? It's 2 times pi times radius. Now remember, the only one missing there, the only value is r. Okay, pi is a number. It's 3.14 blah, 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 blah. And 2 is also a number. So the only one missing there is the radius. And they're telling you it's 64 centimeters. Now they say to you, calculate the area of the same circle. So the area of the same circle that has been doubled in size. Correct to 2 decimal places. So let's first worry about getting this r over there. Okay, let me get a different color. Okay, so with that, can you see that we can find the radius? Okay, so 2 times pi gives you 6,283,185,300. I'm just going to write a few. Radius, because if they're timesing together, it's times r. So how do I get r alone? I'm going to divide with this huge number that takes me so much time to write down. But what you do on the one side, you have to do on the other side. So again, 6.28, and I can't even see it, 313,185,307. Now, if you want to, you press answer in your calculator, you keep that long digit, and you just go and push in the 64 divided by your answer. And then, if you don't know how to do that, then it's best to ask someone, or you can just leave it out and just repunch in all the digits. Okay, so the radius is 10, and let's round off to the nearest 1 decimal, 10,2, and it is centimeters. Okay, but now they say to you, you have to work out the area. So the area is pi r squared of the same circle that shares the radius of 10.2, but it has been doubled in size. So what do I need to do with this radius? I need to times it by 2. And if I do that, I get 20,4 rounded off. And now it's been doubled, and they want you to calculate the area. So I'm going to use the area formula, which is pi times the radius, which is 20.4 squared. And then I'm going to put it into my calculator, which gives you 1,303,8 rounded off centimeters. And because it's now the area, it's going to be centimeters square. Because I kept all my digits, that is what it gave me. But if you went and inserted it as 20.4 in your calculator again, you would have also gotten, or perhaps you would have gotten 1307,4. So it's all very important with the rounding, but in this case, we will always just double check. If you round it off here, it's always best not to round off, but if you have, then it could have been that answer as well. Okay, so I hope it makes sense. Not too bad. So we found the radius first. Then we doubled it because it's a double. Then we went and inserted it again into our area formula. And then we got the area of that doubled up circle. Okay, if needs be, you can also draw pictures for yourself. Okay, let's move on to the next one. Question 6. The following is a picture of an open top fish tank in the shape of a rectangular prism. So very important, it is open top. There is no top to that fish tank. The fish tank has a length of 1.2, a width of 0.8, and a height of 1 meters. Very important. Let's just first check our units. Luckily, they're all the same. Thank goodness. Then they say to calculate the volume of the fish tank. So the volume is very, very easy. It's length times breadth times height, which gives you 0.96 meters cubed. And now they say to calculate the amount of water in liters. Calculate the amount of water in liters in the fish tank if the fish tank is only filled halfway. Okay, and then they say to you can use that 1 meters cubed is 1,000 liters. So again, if you want to use the pirate method, otherwise you could have just said times it with 1,000. But over here, 0.96 meters cubed. We're going to divide up times down. So if you times that with 1,000, you get 960 liters. But very important, it's filled halfway up. So if it's halfway up, you can times it either by a half, or you could have just said, okay, I'm just going to divide it by 2. Okay, so then the total water is equal to 480 liters. Let's just double check. Calculate the amount of water in liters. That's what I've done. Okay, now they say to calculate the surface area of the glass that is made to make this open top fish tank. So again, they reminded me that it was an open top fish tank. Okay, so for the front and the back, I always do it in different stages, front and back area. Then I'm going to do the bottom, not top and bottom, just the bottom because it's an open top. And then I'm going to do the sides. And then I'm going to add it all together. So the area for the front and the back, can you see its length times breadth over there? So remember, all of those are 1 meters. All of them going upwards like that is 1. So it's 1.2 times 1, which we all know is 1.2. But because it's the front and the back, I'm going to times it by 2, which gives me 2.4 meters squared. Okay, now let's quickly have a look at the bottom. What would be the bottom? Can you see the bottom is going to be length times the breadth over there because it follows through like that. Oopsie, something wrong there. But this part over here, the slanting side is 0.8, slanting side 0.8. So it's 1.2 times 0.8. And I'm not going to times it by 2 because it's an open top. So that gives you 0.96 meters squared. And just double check 0.96. And then the sides over here, there's your rectangle, which is 0.8 times 1. And then I have to times it by 2 because there's 2 sides. 0.8 times 1, which gives you 0.8. But because there's 2, we're going to times it by 2. And it gives me 1.6 meters squared. Now to get the total surface area, we need to add all our totals together. So the total surface area is those three added together, which gives you 4.96 meters squared. Let me just always double check. Calculate the surface area of the glass that is made. Yes, that is the surface area. Okay, I hope it makes sense. Moving on to the next one. Again, can you see a right triangular prism? Can you see that immediately the H is going to be what? 3. Yes, you've guessed it. Why? Because it's that Pythagorean triplet, that lovely one that I always want you to remember. 3, 4, 5. Make sure that the 5 is the hypotenuse, which is the biggest one. Then the other two lengths will always be 3 and 4. Another one that you can always look out for is a 6, a 8, and a 10. We love to use those Pythagorean triplets, especially in grade 8, because we want those. Those ones give you nice whole answers. Okay, sometimes you get decimal answers with these. Okay, study the sketch drawn below and answer the questions that follow. Calculate the length of the height of the triangular prism. So I told my kiddos that you can just say H is 3 centimeters then because of Pythagoras. No working out needed. Just H is 3. If you knew it and you've got Pythagoras, we're going to give you all those marks. Then they say calculate the surface area of the triangular prism. So we have done one of those, but let's just do it again. So we've got our 2 triangles. Okay, so the 2 triangles. Plus the 3 rectangles will give me the total surface area. Okay, let's quickly have a look. The 2 triangles, base times height, so 3 times 4. Divided by 2, but because there's 2 triangles, I'm going to times it again by 2. Okay, so 3 times 4 is 12. 12 divided by 2 times 2 gives you this 12. And I just want to check the measurements. It's in centimeters. Centimeters squared. Okay, because we're looking for the surface area. 12 centimeters squared. So now, do you remember my rule that I said? The one that it pops out with, this long side over there. You take the 11 and the 3 rectangles is going to be, let me rather just break it up like this. So the 3 rectangles is going to be 11 times 11 times 11 times. And that 11 marries the 5, the 4, and the 3. Okay, so then it's your front. 11 times 5 is your front, your bottom is 11 times 4, and the back over there is 11 times 3. Okay, so if it's hard for you to see, just remember the one that pops out with, he marries all 3 sides of the triangle, the right triangular prism, sorry. So it's going to be 3, 4, 5. Which is quite easy to see. Hopefully don't need your calculator with that. Okay, and now, this was centimeters squared, sorry. Now the total surface area is all of those added together. So the 33 plus the 44 plus the 55 plus the 12 gives you 144 centimeters squared. So 33 plus 44 plus 55 plus the 2 triangles, 12, gives you 144. Righto, moving on to the next, and we're almost towards the end. So well done for sticking with me and making sure that you understand these questions. We are almost done. Okay, an isosceles triangle. So what does that mean? It means that this one is 5 as well as that side is 5. An isosceles triangle ABC with BC is 5 centimeters and perpendicular height BF is 4 centimeters. So then they tell me that this BF over there is the height, which is 4. Okay, square AC DE has an enclosed circle touching all sides of so just meaning there's no space left there. And then I'll say to you, calculate the shaded area in the diagram if the height of the triangle is 4 centimeters. So I don't know why I said that again, because I have given it to you there at the top. If the height of the triangle is 4 centimeters. Okay, so now we need to use Pythagoras. Now, very important, can you see again, it's the Pythagorean triplet. So if you had to cut this triangle out here, we've got a 5, we've got a 4, and then we've got a 3 over there. So if you can spot those triplets, it's very, very easy to just quickly say that FC is 3. So I'm going to start with that. FC is equal to 3 centimeters. Just wanted to check the units, and that is because of Pythagoras. So you will get a mark for that. You'll get a mark for that. But you don't have to do necessarily all the working out for it. Okay, if you can spot sees that it is a 3 because of the Pythagorean triplet. Again, just reminding you of those triplets. Okay, that is 90 degrees. There's a 3, a 4, and a 5 then. Again, another one that could have been given if it was a 10 and a 6. What do you know that one would be? Do you know it is a 8? Okay, so just try and remember those in the back of your mind. Okay, now for the triangle. Let's start with him because everything is shaded in the triangle. And for the triangle, it is going to be base times the height divided by 2. Now, let's just clear up here a bit. We know that I'm going to keep that going there, that 3 over there. So FC is 3. What would be AF then? Also 3. So AC will give you 6. So the base of that triangle is 6 times the height, which is 4, divided by 2. And 6 times 4 is 24, divided by 2 gives you 12 centimeters squared. And then I'm somewhere going to make a little hearty, and know that is one part of my answer now. Now, how would I get the shaded area? I actually want to do the sum over here so that we've got the picture right next to us. Okay, so if this is 3 and 3, then hopefully you know, or you could see by these stripies everywhere, that this is indeed a square. Okay, so we've worked out that AC is 6. So the area of the square is 6 times 6, which gives you 36 centimeters squared. And now we need to go and subtract this white circle over here, because that's not part of my shaded area. So we need to, from the area of the square, we need to subtract now the area of the circle. So now we need to go and figure out what is the radius of this circle. Sorry, let me just try another color. So the radius, can you see, is going to go from the one edge to the other edge, and it's going to be half of it. So from here to here, do you agree it's the same length as there to there, which gives you 6. So what is the radius? 3. Okay, and the area of the circle then is pi times the radius squared. So it's 36 minus pi times 3 squared, which gives you 28,27433. I'm just writing a few, and then I'm going to lock it into my calculator as the answer, and then say 36 minus my answer. Thus, the bottom shaded area is 7,7. If you round it off to the nearest 2 decimals, 7.7 centimeters squared. Okay, so now I'm not done. So the area of the bottom part is my other hearty answer. So we've got the area of the top triangle, shaded area. Now we've got the area of the bottom squared shaded area. And so the total shaded area is going to be 12 plus 7.7, which gives you 19.7 centimeters squared. Calculate the shaded area in the diagram if the height. Okay, so just always when you're done with the sum, let me just hold it there for a second for you. When you're done with the sum, always go back and just go double check, did I answer what they asked? Okay, all right, so there's the other part of the sum. Okay, let's move on. I think I'm going to skip this one as we've done so many of them. And then this is the last question. Otherwise, the video is getting too long. And again, they say to you, the following shape is a circle placed inside a square. So we know immediately the area of the square is going to be 6 times 6, which gives you 36 centimeters squared. Okay, so that's for the whole thing. But all they want is the area of the shaded part. Calculate the shaded part of the figure below. Okay, so I'm going to do it around the picture. So that is the area of the whole shaded part. So now we want to work out what these parts are equal to. Why do we want to do that? Because there's 4 of them and one of them is shaded. So we need to include this little mister in our answer. But how would we do that? So if you take, let me just quickly show you. If you take the area of the rectangle and you subtract the area of the circle, what are you going to be left with? I'm going to color it in. You're going to be left with the shaded area there. And then if you take your answer and you divide it by 4, you'll be left with 1 shaded area. Does it make sense? Okay, I hope so. So I'm going to start with the sum. I'm going to say it's the area of the square, and then the area of the circle is going to be pi times the radius. Again, what's the radius? If from there to there is 6, the radius would be 3. So pi times 3 squared gives you 28,27. Okay, so now what I'm left with, this 28.7 is the area of the circle. All right, so now if I take the area of the square, and I subtract the area of the circle, again, remember, it's going to leave me these 4 parts over there. Okay, so the area of the square minus the area of the circle will give you, I just want to go place it into my calculator, which will give you 7,72566. Okay, but now we just want one of them. You see, just one of them are shaded. So I'm going to divide my answer by 4 before I round off, which gives you 1.9 centimeters squared if you round it off. Okay, so now let's go back. Let's go look at the question again. They say to you, calculate the area of the shaded part. So can you see it's going to be the area of the circle plus the area of one of those little corners. Okay, so the shaded area is going to be the area of the circle, which is 28.27, plus the area of one of those little corners, so 28.27 plus 1.9 gives you 30,17 centimeters squared. And there is your answer. Okay, so just remember, by adding, subtracting 2 figures, you get the part that is left. use highlighters to see what is going on. Use color. Color is amazing. It attracts you to the sum, and it makes it look pretty, and you want to do it then. Okay, so that is where I'm going to stop. Some of these questions are quite challenging. They're not all so straightforward. Data handling is more straightforward, easy type questions. Geometry, you get the easier and harder type questions. Measurement, they love to throw that into the harder part so that you've got level 3 and 4 questions as well in your paper. So I hope it helped. I hope you do well in paper 2, and please look out for the next video, which I'm going to do on data handling. Have a great day, grade 8s. Bye.